Lonnie Thompson, a distinguished professor in the School of Earth Sciences and a senior researcher in the Bird Polar Research Center. Dr. Thompson is a foremost expert in paleoclimatology, which is the study of climate over the history of the Earth. He has received numerous awards and honors, including the National Medal of Science and the Benjamin Franklin Award, together with his wife.
Yes.
And he's also been featured in every form of media you can think of in this country, including CNN, PBS, National Geographic, and of course, Rolling Stone. Welcome and thank you for doing this today.
Well, thank you, Barbara.
I realize that our students have heard or been aware of the topic of climate change since they were born. In fact, the United Nations Intergovernmental Panel on Climate Change was established in 1988, about 10 years before they were born.
Yes.
So, if you would tell us how climate change, which has occurred over the entire 4+ billion years of the Earth, how this one's different in the last 50 to 100 years.
Yeah. Well, we study the history of climate long before humans became a factor in it. So we look at things like the natural variability, things from volcanic eruptions, which can cool the temperature of the planet for 1 or 2 years. We look at solar variability, output of the sun, very important for the climate of the planet. And on the longer term, we have orbital forcings that impact energy coming to the Earth and ultimately the climate. What makes the last 100 years so different is the rate at which the temperatures are rising, specifically since 1950.
Oh.
And the only explanation for that is a combination of the natural and the human. And in fact, if you look at only the natural variations over the last 100 years, temperatures would not have changed, or they've actually be cooling.
Oh my.
But in fact, they're increasing. And they're increasing because we're changing the composition of our atmosphere. CO2 has risen 40% since the Industrial Revolution started in 1800. And when we look at those changes, and it's not only CO2, it's methane that comes from our natural gas productions, and nitrous oxide that comes from fertilizer that we put on our fields. And all of those are greenhouse gases. And we've known CO2 as a greenhouse gas for over 200 years.
Yeah.
And so the earlier researchers realized that you could increase the temperature of the planet if you change these gases, but they never realized that we developed the technology to remove what were essentially the forests of the past in our oil and the gas, and to bring all that to the surface and release it to the atmosphere over such a short period of time.
I had read that's like 30 trillion pounds of CO2 per year.
32. And it's absolutely mind-boggling when you think about it. And fortunately, we live in a time where right now the ocean is our friend. It's absorbing a lot of that, about a third of it. And there's a real question as you go forward in time whether, in fact, that will remain the case, because certainly CO2 is more soluble in cold ocean water than it is in warm. And over the last 50 years, the surface waters and the deep waters in the ocean have been warming. And we have evidence on the long-term climate history that in the past, when we've had very rapid temperature rises, that they had to come from natural systems. And one of the thoughts is that it was the outgassing of CO2 coming out of the oceans and suddenly coming to the atmosphere. And it's a greenhouse gas. It doesn't matter where it comes from. It will cause the temperature of the planet to warm.
Because if you look at the history, it does jump like a tipping point has been hit. Is that what you're referring to?
Yes. I think if you look at the rate at which, and it's really the rate of change that we're concerned with. The organisms on this planet, including us, given long enough time, we can adapt to changes. It's when it comes very rapidly that the system is stressed.
Yes. Let's talk about that for a minute. For example, I've heard that the growing season has increased by 2 weeks around this latitude. Isn't that a good thing?
Well, yeah. If you look
Yeah.
if you look at the country as a whole, if you go to the west and the northwest and the southwest, it's actually increased by 2 to 3 weeks. And this part of the world, it's the average of 2 weeks. And there's some benefits from that. I mean, it's not all one-sided. If crops can grow longer, you can have better yields. But you also get other things that happen when these things change, and things like pests, ragweeds like poison ivy likes CO2 and likes long seasons. So there are negative things that also come into play. And then we have the issue of our birds. They have evolved over long periods of time, and they have their young so that they match that with when the insects will hatch, and there's a food source for them, and they all have their own cycles. And if you change the system, then suddenly they're not in sync anymore, and these become an issue. And we have other issues in this part of the world, such as ice cover on the Great Lakes. That has reduced by 20% since we had our first observations back in the 1960s. Even though the last 2 winters have been cold, that variability, that's the weather. And when we're looking at climate, we're really talking about a long-term 30-year average of that variability. And probably, at least it's attributed to Mark Twain, said it best. He said, climate is what we expect, and weather is what we get. So the variability has been with us in the weather system for the history of the Earth. But what we're trying to do is to ferret out the average, the 30-year averages of those changes with time.